Hello students, again welcome to online classes. We are in module 4. Till now we have done 3 modules of this chapter. What we have read till now: first, Cartesian product. Cartesian product between two sets. Then relation. Then types of relations. And now we are going to start function. This is the last part, function. Second, let A is one set which contains 3 numbers 1, 2, 3, and B is second set which contains 2 numbers 2, 3. What is A cross B? A cross B, Cartesian product. It is 1, 2, 1, 3, 2, 2, 2, 3, 3, 2, 3, 3. Say this. Cartesian product is a set in which first number comes from A and second number comes from B, and they are called ordered pairs. Write down all the possible elements. This is called Cartesian product. Then, what is relation? Relations are subset of this Cartesian product. If I write down this is relation, and this is called void relation, empty relation, no element is there. If I write down next set which contain only one element, this is also relation. All the subsets are relation. If I write down next relation which contain only 1, 2 and 1, 3, this is also relation. If I write down next relation which contain 1, 2, 2, 2, 1, 2, 2, 2 and 3, 2, it is also relation. See again, if I write down 1, 2, 2, 2, 3, 2, 3, 3, this is also relation. Take 1 number, 2 number, 3 number, 4 number, take all the numbers, 1, 2, 1, 3, 2, 2, 2, 3, 3, 2, 3, 3. This is relation. If A set has 3 elements, B has 2 elements, A cross B has 6 elements, so total relations are 2 to the power 6, 64. From A to B, we are having 64 relations. 64 relations. Now we have to start function. Out of these 64, some are functions. Out of these 64, some are functions. So what is function? See definition. Function. Function is particular type of relation. Any relation from A to B is function. From A to B, if every element of A is related with unique element of B. This is relation. That 2 words important: every, unique. Function is particular type of relation. Out of these 64, some are relation. If every element of A related with unique element of B, every of A related with unique, that relation is called function. If all these elements will come, all will come. See this, in this 1, 2, 3, all are in here. All the elements of A, every element of A, it should be here. But it should have unique image. 1 has 2 image, 2 has 2 image, 3 has 2 image. 1 is related with 2, 2 with 2, 3 with 2. 1 is related with 2, 2 is 2, 3 with 2, 3 with 3. 3 related with 2 elements. 3 related with 2 also, 3 related with 3 also. 3 is related with 2 elements. Here every element has unique image. Every element has unique image. Every element related with unique element. This relation is called function. This is function. Out of 64, some are function. This is called domain in function chapter. In relation chapter, first number is domain. This is domain. In this relation, only one is domain. In this relation, only one is domain. In this relation, 1, 2, 3 is domain. In this relation, first number domain. But in function chapter, this whole set is domain. Because every element will come. 1 will also come, 2 is also come, 3 will also come, all will come. This whole set is called domain. Second element is called range. In relation chapter, first number is domain. In function chapter, whole set is domain. Second example. Suppose A is set which contain 3, 4, 5. B is set which contains 6, 7. Now what is A constant? All the numbers 3, 6, 3, 7, 4, 6, 4, 7, 5, 6, 5, 7. All will. If there is any relation in which 3 is also there, 4 is also there, 5 is also there, all the numbers they are here, this relation is called function. And every element should have unique image. If I write down relation 3 related with 6, 4 related with 6, 4 related with 7, 5 related with 7, 5 related with 6, 1, 3, 4, 5. 3 is here, 4 is here, 5 is here. But 4 has 2 images. 4 has 6 also, 4 is related with 6 also, and 4 is related with 7 also. 5 is related with 7 also, 5 related with 6 also. So 4 has 2 images. 5 has 2 images. 5 is related with 2 numbers. 4 is related with 2 numbers. This is not a function. If every element of A is related with unique element of B, this number may be same, this number may be different. But every element unique image. Every element unique image. That relation is called function. And in function chapter, this whole set, this is called domain. And this set is called codomain. In relation chapter, this is relation. What is domain here? Only one. This is domain. What is range? Only 2. First number is domain. Second number is range. First number is empty set. Second is empty set. So first number is domain, second number is range. In function chapter, this whole set is domain and second number is range. And this whole set is codomain. Let us do one question. Let F is any relation on Z. Let F is any relation on Z such that F is equal to AB, A plus B, such that AB both belongs to Z. F is any relation and this is called ordered pair and both number belongs to Z. Now question is whether this relation is function. Whether this relation is function. See, relation is function. Now relation is function when every element has unique image. Every element unique image. It may be same, it may be different, unique image. image is this element's image is same, this element's image is same, this is same, all element related with same number, but all have same image, unique image. All have unique image. Suppose it is 1, 2, 3, 4. Suppose it is 5, 6, 7. 1, 2, 3, 4. All are related with same number, but all are having one image, unique image. It is function. If I say 1, 2, 3, 4, 5, 6, 7, 8. 1 is related with this, 2 is related with this, 3 is related with this, 4 is related with this. There may be some number more, but every element has unique image. It may be distinct, it may be same. If every element unique image, it is function. So this is the relation, and question is whether it is function. We have to check. If every element, here element, has unique image, then it is a function. If any number from domain has two images, suppose it is 1, 2, 3, suppose 4, 5, 6, and where 1 is related with 4 also, 1 is related with 5 also, 1 has 4 image, 1 has 5 image, this is also image, this is also image, then it is not a function. This is star domain and this is star range. So in domain it is multiply and range it is plus. So let us take two numbers. Come check. Let A is 2, B is 3. Take any two number. So what is product? Product is 6. What is sum? Sum is 5. According to this relation, therefore 2 or 6, 5 belongs to F. 6, here multiply, here sum, 6, 5 belongs to F. It means 6 is related with 5. First number is domain and second number is range. Then take two numbers more whose product is same. Suppose I get 1, 6. So that product will become 6. And what is sum? Its sum is 7. Now 6, 7 belongs to F. Because first number is product and second is sum. First is product, second is sum. Here 6, 5. Here 6, 7. 6 is related with 5. 6 is related with 7. 6 has two images. And when 6 has two images, therefore F is not a function. It is relation, but it is not a function. Because one number has two images. First number is star domain, second number is star range. If any one number has two images, it is not a function. If any student say, sir, why you have taken this example? Okay, take any other example. Another, let A is -3 and B is 4. Because we get integers. It may be positive, may be negative. What is product? Product is -12. What is sum? Sum is -1. And therefore, -12 -1 belongs to F. And this is domain, this is range. So -1 is related with -1. Now you take two numbers in such a way that their product is -12. Any two numbers, but product should be same. So take 2 -6. So that product is -12. And now sum. And when we add that, answer is -4. So -12 is related with -4 here. It is belongs to F. This also belongs to F because it is F. So here -12 related with -1, -12 related with -4. So -12 has more than one image. And when any number has more than one image, therefore F is not a function. It is a relation but not a function. So relation, it may contain empty set, it may contain one number, it may contain relation any amount, 1, 2, 3. But function, every element of first set should be related with unique offset. So this is relation but not a function. Let us go another question. Suppose function is, let fx equal to 2x square plus 3x. Let fx this is any function from R. Let it is any function. And now question is, find out f of fx. Find out f of fx. If question is find out ft, if question is find out ft, instead of x you are to add 3, means 2 into 3 square plus 3 into 3, and it is equal to 18 plus 9, 27. If here in domain it is 3, put x into 3 here. If question is find out this, so domain is -1, put -1 here. 2 multiplied by -1 square plus 3 multiplied by -1, it is 2 minus 3 minus 1. So this is called domain, this is called x. Instead of x you are to write on 3, instead of x you are to write on -1. Now question is find out this. When we are to find out f of fx, firstly write the value of fx. What is fx here? 2x square plus 3x. If question is find out f of fx, firstly write the value of fx. Now this number, this 2x square plus 3x, it will become x for this f. For this f, instead of x, you write on this. Instead of x, you write on this. Means 2 multiplied by, instead of x, write on 2x square plus 3x whole square. 3 multiplied by 2x square plus 3x. Wherever there is x, you write on this. 2 multiplied by this number square. 3 multiplied by this number. And now, it is 2 multiplied by, open the whole square. First number square, second number square, plus 2 times they are multiplied. 2x square into 3x, a plus b whole square form. And similarly here multiply, I'll get 6x square plus 9x. So next step, it is 8x4 plus 18x square. It is 2 into 2, 4, 4 3s are 12, 12 2s are 24. 24x cubed. Then 6x square plus 9x. In the end we get 8x4 plus 24x cubed plus 24x square plus 9x. It is value of f of fx. Firstly, write on fx. This fx will become x for this f. Instead of x, write down this value. You will get both the answer. Second, next question is, f is the function, fx equal to 1 upon this, and question is find out f of fx. Say this. F operated on f operated on fx. So firstly, when we are to find out f of fx, firstly write the value of fx. Fx value is 1 upon 1 minus x. Write first value of fx, it is 1 upon 1 minus x. Now this value is x for this f. Wherever there is x, you are to write out this number. This will become x for f. So in next step, f of, instead of x, you are to write out this. It is domain for this f. It is x for this f. So it is 1 upon 1 minus, instead of x, write on 1 minus 1 by x. Instead of x, write on this value. Now what is this? It is f 1 upon, what is LCM here? 1 minus x. It is 1 minus x minus 1, it will cancel. In the end we get it is equal to f 1 minus x in the numerator divided by minus x. 1 minus x in the numerator divided by minus x. Or you can write it is f of x minus 1 upon x. Take minus common, minus cancel, it is f. Now again I have to find this value. Again instead of x write down this. So it is 1 upon 1 minus instead of x write down this x minus 1 divided by x. Wherever there is x write down this value. In next step it is 1 upon take LCM x minus x plus 1. It will cancel and now this x goes to numerator. Answer is x. So question is find out f of x fx. Firstly write the value of fx. Now it will become x for this f. So wherever there is x write down this value. Take LCM. 1 will cancel. This 1 minus x goes to numerator. Divide by minus x. To cancel this minus, take minus common, minus cut, I'll get this value. And now again it will become x. So wherever there is x, write down this value. 1 divided by 1 minus x minus 1 upon x. Take x LCM. It is x minus x plus 1. X cancel. This x goes to numerator. This is the answer. So whenever we are to find out this value, first we start from domain, write down this value. Again it is x, find the answer. Again this is x, find the answer. See next question. Suppose fx equal to x5 minus 1 by x5. And question is find out fx plus f1 by x. See this question. Fx is this, find out this. Now let's start fx plus f of 1 by x. Now what is fx? x5 minus 1 by x5. This is fx. Now I need f of 1 by x. So wherever there is x, write down 1 by x. Wherever there is x, write down 1 by x. Write 1 by x here. Write 1 by x here. Instead of x, write down 1 by x. In next step, it is x5 minus 1 by x5 plus. It is 1 by x5 and this goes to numerator. It is minus x5. 1 power 5 is 1. And now x5 cancel with x5. This value cancel with this value. So when the question is fx is given to something and you have to find out this value, write the value of fx and when I need this instead of x, write down 1 by x, find this value and then cancel.